Hello everybody. In this video I'm gonna go over how to find the domain and range of a given equation. So we learned that the domain is a value of input that goes inside of the factory, and the range is output. So we can list them as domain equal to a comma b comma c, and range is set of 2, 5, and 8. But not all the time I will give you guys a factory like this to look at the input and output. Sometimes I give you guys an equation. For example, f of x equal to 5x divided by x minus 2. So this is a function, and my question is find the domain of this function. Definitely is more complicated than this one, but if we know the technique, it shouldn't be that complicated. So let's solve this one. So if I give you guys equation, the way to find the domain, we need to categorize the function to mostly to three different functions. If we have a linear function, like if we have mx plus b, or if we have a quadratic equation, or any type of polygons like a polynomial, like ax to power n plus bx to power n minus 1. As long as there is no radical, if there is no radical and there is no negative exponent and there is no fraction, if we don't see those things, the domain will be all real number. So the domain will be all real number for any set of polynomial. Not negative number, no fraction, no x on the denominator, then domain will be all real number. In this example, we have x on denominator, x minus 2. Basically, we have a rational function. The way we solve the domain, we're going to say domain equal to all real number minus any number that makes the denominator 0. In this case, 2, if you plug 2 on the denominator, you get 0. So you're going to say r minus 2. I mean, in the number line, from negative infinity to positive infinity, we accept all the number, but not 2. So you can say from negative infinity to 2, parenthesis, and from 2 to positive infinity. So this is one way to show the domain, and this is another one. Let's have another example. G of x equal to 1 over x plus 3. What's the domain of G? Because there is x on denominator, so you should know the way you're going to start. You're going to write all real number minus a set of number that makes the denominator 0. What makes the denominator 0? You're going to say x plus 3 equal to 0, then x equal to negative 3. So you get x equal to negative 3, you will move it over here. So this is going to be the domain. H of x equal to radical x plus 5. Now you're going to find the domain of this. So we are dealing with radical. So this type of notation only works for the rational. For example, let's say there is a factory here, 16 go inside, we get 4. Let's say 9 goes inside, we get 3, and 1 goes inside, we get 1. So you know we make it radical 16. Radical x is a relation between input and output. If somebody plug -9, what's going to happen? If -9 go inside of the function, we're going to have radical -9, and this is going to break the factory. So before to sell your product in the factory, we need to have some limitation. For example, this example, we're going to say we cannot have negative number for this factory. If we don't say that, if somebody put -9 or -25, we're going to break the factory. So that's why we're going to say domain going to be x greater than equal to 0 for this example. That means we only accept positive. So now let's say there is a factory that the relation between input and output is x plus 5. So we're gonna, so inside of the radical has to be positive. We're gonna say x plus 5 greater than equal to 0, because we can have 0 on the radical. Then we're gonna solve for this x. We're gonna have x greater than equal to -5. Then so we solve for x, and this is actually the domain. But the way we're going to write it, you're going to say domain equal to a set of x such that x is greater than equal to -5. If we show it on the number line, if I do it here, on the number line, if here is -5, we're going to accept everything included -5 to positive infinity. So some of the function will be tricky, and in the last couple example, I didn't ask you guys what is the range. Finding the range is different technique, but first we have to be good on the domain, and then we work on the range. Okay. Now let's have some piecewise function. H of x equal to set of 2x when x is greater than equal to 0, and h of x equal to x squared when x is less than 0. So this type of function, that one function here has two pieces, they call it piecewise. Sometimes 3 or 4 different functions belong to one function. If we're going to picture this one, for example, we have a factory, bigger factory, let's say to a store, and when we put the input, for example, when 5 go inside, there is a checkpoint here. They said if 5 is greater than 0, you're going to go up and do some calculation, 2 times 5. If is less than 0, for example, they're going to just put a square. So if 5 goes inside, 5 is greater than 0, going to go up. But let's say if I put -3, if -3 go inside of the factory, at the gate they're going to check it, is that greater than 0 or is less than 0? -3 is less than 0, so it's going to go to this. -3 squared will be 9. So this is visualizing it. Anyway, so now they're asking us to graph it, or sometimes they ask us to evaluate. Before we graph it, let me ask you guys, what is h of 4? So h of 4, we have to plug it on this function or this one. Because 4 is greater than 0, greater than equal to 0, we're going to pick this. So it's going to be 2 times 4, which is 8. What is h of negative 5? Because negative 5 is less than 0, we're going to use x squared. We have negative 5 squared, which is 25. Alright, for the graphing, let's graph the first one. First one is 2x. So you're going to graph y equal to 2x. 2x is linear, y-intercept is 0. If we graph it, you're going to have something like this. There's a line. This is so 0, 0, 1, 2. Let me use the ruler. This is a graph of 2x, but y equal to 2x, only x is greater than or equal to 0. So this is 0, here's positive infinity, here's positive 1, positive 2, so here, the other side is negative. We don't accept the negative part, so we need to erase the other parts. So we erase it here. So only this part we accept. Now let's graph the other part of the piecewise function, which is x squared. X squared is a parabola. If we graph it, it will be something like this. But y, or h of x, equal to x squared, only x is less than 0. So only for this part. That means we need to erase the other parts. So this will be the graph. I think it's enough for this video.